Yeah, let's see the previous class. In the previous class, we have discussed about the butterfly and its coding. Just it's a recap. This is the main butterfly block, in which we have three blocks. Generally, a butterfly consists of a multiplier, adder, and a subtractor. Okay, just it's a recap section. Let the A be are the inputs and O1 as well as O2 are the outputs. Here for the multiplier, the inputs to the multiplier are B and omega, and for the adder it is A, and the output of the multiplier. Similarly for the subtractor, the output of the multiplier and the A. Okay, so we will get an O1 output as something A plus B into omega, and similarly for O2 we will get output A minus B into omega. So generally for a butterfly, it consists of internally three modules, and these three modules, adders, subtractor, and multiplier, are instantiation to form the butterfly module. This is the butterfly overall module we require. It consists of inputs A, B, and W, and outputs O1 and O2. So the code for it we have already discussed. Let us consider these three modules. We have to first write the code for these three modules, and thereafter we have to write the code for entire module of butterfly. Let's just a quick recap of the code. Module name, and the input parameters of inputs and outputs. Okay, module, adder, it's an adder module. Let's consider this is an adder module code. It consists of I1 and I2 and O, as we already noted in the book. I1 and I2 are the inputs for the adder module, and O is the output. So input wire 7 down to 0 I1, and input wire 7 down to 0 I2, as the inputs to the adder are 8 bits. So we will get an output of maximum of 9 bits. So we have to get declare output as 8 down to 0, and finally we have to assign the what is the required function of this adder module. Something output O is equal to I1 plus I2 and module. This is the adder module. Similarly, we have to return multiplier module and the subtractor module. The difference is just in the assignment statement only. Now after completion of these three modules, we have to finally assign all the three modules in the butterfly module. So the butterfly module also syntax is same as that of the previous modules. Module name and the parameters of the inputs and the outputs. Next you have to declare the input wires and their step sizes and the variables which we have declared. So if these are the inputs, we have to declare as input and output wire, and the step size 7 down to 0 and 8 down to 0, and the variables which you have declared. So the statement should be let's forget this statement. So we have to instantiate the adder module, subtractor module and the multiplier module in the butterfly. So the syntax for it is module name, some instantiation module, a name which you have to declare internally, and this name should be not in this form. We should have our own forms. Let's first for the multiplier, because we have write multiplier, because in the block we have first consider multiplier, thereafter we have to adder. So because the in the output you get multiplied output as well as multiplier output as well as sorry, firstly because first if you get multiplier output, then we have to add it, with and it is given to the input to the adder module. Okay, is clear? Okay, so the syntax for it is the module name which you have previously declared, module name, and the instantiation module name which would be our own choice, and we have to declare the internal connection words. Let's suppose go to the multiplier module once. Here we give the inputs I1 and I2 and O as the inputs and output parameters, where I1 and I2 are the inputs and O is the output. So we have to connect I1 to which for the output. So let's look at the multiplier output. Is suppose it is these two inputs. Here it is I1 and here it is I2. This B should be connected to I1, W should be connected to I2. The case may be reverse of your own choice, but B should be connected to I1. So here what we have written is B should be connected to I1 and W should be connected to the I2 as two inputs. The output is O, which is multi-one. We have declared it as multiple one out. So the syntax for it is, in the brackets you have to written as dot something dot. This is a multiplier module. So in the multiplier module the inputs are I1 and I2 and the output is O. So dot I1 in brackets you have to declare to which port we have given, B. For the input I2, similarly for which of the input ports we have given, omega. So these are to be written, and the output should be some output, and we have declared it somewhat as multiple one out. Okay. As this is an internal connection, you have to declare this internal connection in the year itself or before instantiation of this module. So you have declared it as a wire 15 down to 0, multiple one out. As it is a multiplier, if you multiply two 8 bits, we will get a maximum of 16 bits. So you have to written as 15 down to 0, or even we can written it as like okay, or we can declare here itself also. Okay, The next module is, let's suppose look at the adder module, and the subtractor module is similar to it. Okay, in the adder module, add same as syntax of multiplier, module name and the instantiation module name in the braces, the ports to which it has to be connected. Let us suppose look at this adder module. For the adder, the two inputs are I1 and I2. These I1 and I2 are connected, one input from the multiplier and one input from the A. This is the connection. Okay, so let us suppose multiplier output is connected as one input to I1, input port of adder to as I1, and A is connected to I2. Then as the multiplier output consists of 16 bits, but the adder module consists of only 8 bits, we have to written like this: dot I1 in brackets, to which it has connected the internal connection multiple one out. So multiple one out, and we consider only MSB bits, so 15 down to 8. Similarly, for the second input, we have connected to A, so if you have connected I2 to A, dot I2 in brackets A, and the third input O is connected as output, so we have to declare it as O1. This is the output O, and we have declared it as O1. Okay, for it no problem. Similarly, for the subtractor module, it is similar case, and so end module. This so far we have discussed up until right now, and just this video is just for the recap of the previous one which we have